All right. Good morning. My name is John Galloway. I'm hosting the ASP.NET Community Stand-Up, and today we have Cory Nelson on, and we're going to be talking about flexible HTTP APIs.
Hello, folks.
So awesome. Yeah, this is fun. You tweeted about this late last week, and I was like, let's go for it. Let's talk about what you're looking at. So this is an early design, right?
Yes, it kind of started very late last year. We were kind of interested in what performance we might be leaving on the table with HTTP clients object model. So I wrote a little pet project saying, what is, if we just go completely for performance, how much can we get? That way we know kind of the maximum performance that we want to reach with HTTP client.
Awesome.
And we realized that if you really need it and you're willing to use kind of a different API, a harder API, that you can go quite far.
Cool. All right. Well, we will dig deep into that in a second. Let me start, as we always do, with the community links. So here we go. There we go. As always, we share the links all the different ways. They're in the chat. They are also, I got a banner on the screen here. Cool. All right. So I will just start going through these. This is a fun one. This got forwarded to me over the weekend. This is, oops, good old Teams. This is a Blazor WebAssembly builder. So this generates a business application. So they actually have a lot of cool stuff right here in the page. I'm going to scroll to the bottom. And the idea here is we go through and define our entity. We go through and map out our columns. And it actually, they go through, you click next, and it actually generates out this cool, just a simple data editor, and it has things like Excel export and all that kind of stuff. So I thought that was pretty neat. It's amazing to see. Yeah, it's amazing to see the stuff that people are building with Blazor and WebAssembly and being able to do all that cool stuff on the client. So
yeah, I've noticed a lot of excitement about Blazor. It's pretty great, the things that people are building in it.
Cool. All right, so another Blazor link we got here. This is continuing a series from Andrew Locke. He just writes stuff all the time. Last week, he was writing about discovering routable components in Blazor. And so he was using reflection, using different techniques to go through and discover the different components. And then he takes it a step further and he says, why don't we hook up some source generators and build out our menu component? So this is interesting. It seems like be useful to play with, especially in a case where maybe you have a pretty complex or dynamic Blazor application where things could change. Oh my gosh. Okay. So here we go. I need to, well, there it goes. Forget it. So Teams, let me rant just a second. Teams is the one thing that does not respect when you go in here and you turn on focus assist and all that. Teams does not respect that, and it's frustrating to me. All right. So cool. Here's the example where, file new project Blazor. You've got, counter, fetch data, and the index. So here it goes through and discovers those. And then why not actually generate this navigation? The navigation you get in file new project is hard-coded, right? So here he goes through and shows how to do that using a source generator. So he's got two classes. He's got an individual class for each page. And then he's got another one that's a collection class that holds all of them. So he goes through and shows, shows how to generate those routes. Here's all the stuff actually going through the semantic model, mapping through, finding the different routes and stuff, and executing. So it's kind of cool stuff. And then as Andrew always does, that I love, he goes through at the end and kind of talks about, here's what we did, here's how here's some thoughts on it. So he talks about showing off the attribute setup and then the limitations of it that as of now, this is like you have to set up like a fully qualified namespace on the attribute and some stuff. But it looks like an interesting, and I can see people taking this a little bit further. So
yeah, this is interesting. It kind of reminds me of the early scaffolding work that we had.
Yeah. Yep. And I think that's I haven't heard, like, scaffolding is really cool as a concept, and I think especially with Blazor that there's some opportunities to go further with that, take a kind of a second look.
And the source generators are fantastic for this kind of stuff. We're seeing all sorts of cool uses for it.
Yeah. Yep. Cool. All right. So Brandon writing about creating Azure functions using .NET 5. So this is kind of all the stuff on that. Azure functions kind of under the hood is actually running on the LTS version of .NET. And so that's kind of the full underlying supported system. So here he walks through, and he's got a sample project that he uses Git trends. And so he walks through updating it to .NET 5. And, really pretty straightforward using the SDK, updating NuGet packages. There is the non-Windows workload and the kind of setup stuff in the project. And then, walking through all the other kind of things that you need to look at as you get deeper into it, like DI and stuff. So he goes through all the things, deploying and everything. So anyways, it's useful. It's kind of an interesting in between place with Azure Functions right now because they do run on the LTS version, and I do understand kind of why you do that. But then on the other hand, there's some good exciting stuff in .NET 5.
Yeah, this is great. Azure Functions are super cool, and being able to write them with .NET 5 is just going to get free performance benefits and all that nice stuff that we added.
Yep. Cool. All right. Here is a huge one. This is so Richard and team did a really deep dive into .NET container images. This is how they're building and maintaining and all the stuff for the images. I've read through this thing twice and my head's still spinning. If you're a container guru, there's going to be like a lot more that you can pull out of this, but it's really pretty cool. So there's all the stuff, how the Docker files are managed. There is because they're pulling in from different licenses, different maintainers for all the different packages, they're kind of like mixing all the stuff together. They talk about how they build things, how they manage vulnerabilities, which is a big deal because any level in the stack can have vulnerabilities, and they need to be able to service them. Mm-hmm. All the different kind of Linux base images because they run against multiple base images, and then some handling distros and stuff. Windows as well. .NET release policies. This is another interesting thing. Is the Microsoft Container Registry, which is kind of the actual kind of final home of the Docker packages produced by Microsoft. So this is kind of where you will always find them. And then he ends up at the very end with some tips. And I think the tips are just useful stuff as far as actually building and consuming. So.
Yeah, I have to admit, I know nothing about Docker. I might end up reading this to kind of learn a little bit more about how we're using it with .NET.
Yeah, it's interesting. There is a lot there. If you know nothing about Docker, I would recommend finding a friend who knows something about Docker to walk you through it. I have done some Docker, and this is still, there's quite a bit here. But I really appreciate this for a few reasons. One is that the amount of kind of care and thoughtfulness that goes into building these images, getting them released quickly as part of the releases, and making sure that they're maintained. I also appreciate just the thought that goes into writing up these kind of posts. Richard does a lot of work on these. I'm copied on the repos, and I see all the comments and all the work that goes into writing these up. And there's just the whole team put a lot of work into this.
Yeah, and I think this is useful sort of as the greater community. I'm sure there are people out there trying to build their own Docker images, and they can kind of see how we've managed to do it and maybe get some tips from that.
Yep, exactly. This is something I'm really excited about. There's actually an AKAMS link for this that I've got that's included in this. We've got this coming up February 26th. This is a beginning of a series with two great friends here at Microsoft. So Jamie Singleton and Cecil Phillip are launching this. And so this is a series on learning.net. It's beginner friendly. It'll help you get started. If you have if you're learning a topic, this is a great place to go. But also if you have maybe, if you know students or young people that are on your team or whatever, that are just getting started learning a concept, this is an awesome way to get started. So this is cool. This is kicking off on the 26th. It's relatively short. I think it's a couple of hours, and it's just walking through some REST fundamentals, API fundamentals, just getting started. And then kind of ending up with some resources and where to go next. So I just can't say enough how excited I am about this. Jamie is awesome. She works on my team, and I'm just really happy to see her kind of kicking this off. So.
Yeah, this is great. I love seeing anything that brings new developers to .NET, helps them get a jump start on this stuff.
Cool. Yep, Cecil's on the chat here. Yes, it is going to be awesome. This is great. Cool. All right. More API fun. So Brady Gaster has been writing a blog post series. And so Brady is like, he gets started going, he'll be like, yeah, I'll just talk about this and this. And then it's like, it turns into like the book, So this one is really cool. And it's on creating discoverable HTTP APIs. So this is, so we had a question in the chat. At the end, after I go through all these links, I'll chat the link out again. It's a roll up of all these. So you'll get the links, and it'll also be in the comments and stuff. So this is on creating discoverable APIs. And the idea is really that you want to design your API as it's like the user interface for your application from a consumer point of view. So you really want to put some thought into it. So he talks about creating something that's going to have, a clear discoverable API.
Yeah, this is cool. I've used Swashbuckle kind of when it first came out a little bit, and I thought it was fantastic. So it's great that we're adding, more support and guidelines on how to use this.
Yep. And there's stuff that's been built in for a few releases now that people you kind of have to turn on. And so I talked to a lot of people that don't know about these, or they'll do file new project and just start creating APIs, and they're not getting all the benefit of this stuff. Mm-hmm. So he talks about how to set up your produces consumes, how to add those attributes in, configuration in your project, and turning on the stuff in your CS proj. There's a few steps you need to do for this. The nice thing is most of this is one-time setup. You set this up in your project, and then going forward, you have an awesome API. So he walks through. It looks like a super long post, but there's a lot of screenshots and a lot of code blocks in here. I know because I helped him post it, and I did the code formatting. So anyhow, it's just really cool. This is worth reading through if you or your team are building APIs. So.
Yeah, and it might seem like a bit of work, but it becomes so secondhand getting through this, and your customers who are using your API will love it. I've had so much good feedback from the Swashbuckle docs.
Cool. Yep. So he goes through this. Now, part 2 is he talks about open source API packages and tools. So this is like the mother lode of like all the amazing stuff. If you're building APIs day to day, like there are a lot of great packages out there. So he talks about the generation and swag and swashbuckle. So Francisco asking on the chat, yes, the talk will be available later. This will go up on our YouTube. So it talks about swashbuckle, Microsoft Open API. Talks about versioning, which is a difficult thing to get right. So this is also useful to use, and not just kind of halfway do it or do a convention base.
Guilty of doing that a few times.
Yeah, and this is nice because this is actually supported, like in Swagger. It's got support for versioning.
Oh, that's so cool.
Then he's got some other things going deeper with some more community things. So he's got refit, the HTTP REPL, which is really cool. So command line exploration of APIs. This REST client for Visual Studio Code. So there's a few options here. This one is a community one that's really neat. There's also this network console. This is an experimental feature from the Microsoft Edge DevTools team. So there's a few ways you can use this. One is that you can go in Edge and you can turn this on. You go in experimental and turn this on under the experiment. So you go settings, experiments, and turn that on. But there's also a way that you can set this up in the in VS Code, and so if you can look that up. There's a VS Code experimental Edge API stuff. So the Edge DevTools team is doing a lot of really cool experiments, and they call them experiments. They're kind of early on and kind of, getting ideas of how they work for people. But I think this is really neat.
Yeah, that's so powerful. The first thing I tell anyone who's making HTTP calls or an API is learn how to read at least HTTP1 and get one of these tools, because as soon as you see the actual request that's going, it's so much easier to diagnose than going through your big C# project.
Yeah, exactly. It's so much easier to explore and understand, and also test. You're actually interacting with the API, so you can see what the response is instead of guessing.
Yeah.
Just the whole, and then he talks about frameworks built on top of APIs, so like Carter Project. So there's more to come. We've got some more. So this is a 4-part series we've got planned out. So, and then I'm going to end with 2 more links, and these are just the ones that got my attention about the show. You tweeted about this design doc, and then you've also got this network toolkit project.
Yeah.
And I just had to show this off. A new thing that I've been using to explore APIs when people tweet over or whatever, I see a GitHub link come over. There's this new thing, GitHub 1 second, that I saw on Hacker News. And you replace in the URL. So where it says github.com, I put in GitHub 1S, and it actually just shows you the code in a web-based VS Code looking.
That is really cool. I love that.
Yeah. So a real quick way to just kind of what does this code look like?
Yeah.
So yeah. So I'm all set there. I will share over the links again in the chat, and I will turn it over to you whenever you're ready.
Cool. Let me load up the API docs.
All right. You all set?
Proposal. Yeah.
Okay.
All right. So you may have been here for the start of the chat. This kind of started as a performance test to see what is the best performance we can get for HTTP and .NET. This is super important to certain customers that just have massive amounts of requests that need to go over, and you're willing to sacrifice a little bit of the HTTP client, like the really nice object model it has, in order to get more performance. And also flexibility. HTTP client does so much for you. Sometimes you don't want that. Sometimes you might know your scenario so well that you want to have full control over everything. And that is what this API gives you.
So to clarify, because there's two sides on an API conversation, this is all considering the client side, right?
Yes, this is the client side. We are interested in server side, but we're not exploring it right now.
Okay.
Yeah. So some of the things that this does is, in order to use this, you kind of have to know a little bit more about HTTP than you might today. It's because it's set up to put you in so much control. You also need to know how to use that control. And some of the scenarios that this allows is, you can open a connection without making a request. So this can be really great for, your 99 percentile times on your APIs, if you're talking to microservices or whatever. Typically, the first request you make will take a bit longer because it has to open a connection, do all the handshaking stuff, and this kind of lets you just open the connection beforehand and try to save that latency. We want you to be able to bypass the connection pool. One of the things about HTTP client is to be performant behind the scenes. When you make a request, it will keep the connection open, so the next request you make will go on the same connection. And it will open, potentially hundreds of connections for you depending on your workload. But sometimes you want to either make your own connection pool, or you know that you only need one connection, or maybe you need specifically a HTTP2, maybe your gRPC, and you need to use some HTTP2 features. So this really lets you kind of get at the protocol level parts of HTTP that HTTP client doesn't currently let you do.
We had a question come in on the chat from Carlo. What level the connection's being made? Like, does it include the TLS handshake?
Yeah. So these APIs here, let me kind of move down a little bit. We're splitting them into kind of three groups. The low-level APIs just operate on stream, so they don't open the connection for you. You need to call socket.connect. You need to add TLS. It doesn't have to be on a socket. You might be going through a named pipe, or any special thing. I know there's RDMA is becoming popular, IOU ring, all these sorts of things. You might want to replace the socket implementation with something else. So that requires a fair amount of work, and that's part of what I'm talking about. Of you need to know a little bit more about what's going on in order to use them properly. The next layer up is what we're calling the compositional APIs. So these are the more opinionated APIs, and they do a little bit more for you, such as a connection pool or opening the connection for you, managing TLS, all that sort of thing. And then on top of that, we have the high-level APIs. This is essentially the HTTP message handler that you would give HTTP client. So if you want to if you want to manage your own connection pooling, but then also still use HTTP client's really rich model, you can use the high-level APIs to kind of wrap the lower-level APIs.
Okay. This reminds me in a way like how ASP.NET in general has moved. Like, for instance, the whole kind of middleware approach and kind of breaking things apart. So you're paying for what you want to use. And if you want to get down and kind of sculpt your, like what you're using and turn everything off, and then you can do that. So
yeah, I have a C++ background. There's a very common phrase that we use in C++, don't pay for what you don't use. And this API really tries to reflect that and kind of bring it into people who need to make HTTP calls.
The layering is important because you want to be able to, like, for the cases where you really want total control, you want to turn exactly the bits on and off, like it's great to be able to get to that level. But I like how you've got this kind of layered. So you also do have high level APIs on top of that. So you don't have to do all that if you don't want to.
Exactly. It gives you just the amount of control that you want. And I suspect 99% of people will not need to use these APIs. HTTP client is actually very performant. It allows you to do most of the things that you need to do. But if you have, maybe you're making a REST client for your company's APIs, and you are comfortable using these APIs to give your library a performance boost, and you can still make your API easy to your customer, but you can handle it behind the scenes to kind of give them a performance boost. That's kind of one of the scenarios we're looking at. Another is if you just need to make so many requests and you need perfect control over timings and everything like that, then this API is going to be for you. But the compositional model really lets you plug in at any layer that you need to.
Okay.
And part of the performance changes in here is HTTP client. It has a whole lot of allocations that are completely necessary just to use it. You have the request and the response message, you have the headers that you put into it, the content, all these sorts of things that they're usually pretty cheap and don't matter, because in typical scenarios they will stay in your Gen 0 GC heap, and that is super cheap. But if you really truly need performance, you can use this and use spans. So spans are useful because you don't have to allocate strings and URIs. They also allow you to do some funky stuff with HTTP. So HTTP, it actually doesn't specify an encoding for, let's say, header values. Typically, we tell people try to use ASCII because that's the only thing that works everywhere. But sometimes you need to send some UTF-8 thing, and your server specifically knows how to handle UTF-8. This would let you do that. You can send whatever encoding you want to. Another interesting thing about this is how we're doing validation. So one of the customers that we're interested in is the YARP project, which is Microsoft's reverse proxy. And in the case of a reverse proxy, you have already accepted a request. A request has came into your proxy, and everything in it has presumably been validated enough to work with HTTP. So you might want to skip validation altogether. You can also use this, maybe in your own code. You're willing to go through a bit more testing, make sure you don't break stuff. You can have some just sort of spans cached somewhere, some byte arrays, and bypass validation altogether. And something that will make someone like David Fowler jump for joy is zero allocations. So
Right.
as you're using this, it actually makes no allocations once you've used it for a little bit. And this is not just good for performance, but if you are having performance issues in your application, you can run through the Visual Studio Profiler, and removing a lot of the sort of junk that you may not care about from the the libraries that you're using can be super useful. This will help you kind of clean that up and see only the allocations that you are making. So it goes beyond performance. So as I said, the low-level APIs, they're built on top of Stream.
Mhm.
I know some people are asking for pipelines. It's something that we're looking at. It's important to know that stream and pipeline, one is not necessarily better than the other. There are trade-offs to each of them, and we want to make sure that this offers the most high performance possible. So kind of evaluating both to make sure that we choose the right one right now.
Can you talk about the difference between stream and pipeline?
Yeah. So Stream is kind of the traditional model of doing I/O. Stream lets you just read and write into and out of byte arrays, or just memory of byte. And pretty much everything in .NET right now is built around streams. So if you want sort of compatibility with everything, Stream is kind of what you want to use. But it's not always the best choice if you go after performance. Pipelines is interesting because it kind of takes away a lot of the worries that you need to make with streams, such as how do you buffer, how do you handle parsing out of that buffer, how do you efficiently write bytes into that buffer. Pipelines are one thing that's really cool about them is it can, in some cases, avoid a copy that Stream pretty much always needs to make when you go from, your byte buffer to the kernel buffer of the socket. And in most cases, people aren't using that. But if you want to use something like registered I/O on Windows or IOU ring, RDMA, pipelines can be really great to avoid that copy. And in some cases, to avoid a kernel transition altogether, which makes your app even faster. But the object model is very different, and it can require a bit more thought to use, despite doing a lot more for you. There are certain cases where you may not want it to do something for you because you might know your problem just a little better and be able to do it yourself a tiny bit faster. So that's the sort of trade-off we're looking at. It's not the sort of thing that we expect most people to worry about, but this API is being designed not for ease of use. We're kind of saying we want the most performance possible. So if you have to do something weird with it to get that performance, we're okay with it.
Yeah.
Yeah.
Okay. And is it something where you make a choice at an application level? Basically, you're using streams or pipelines, and you basically make your pick and you stay with that, or is there some way to kind of interoperate a bit?
You can interoperate. There are built-in sort of wrappers that let you expose a stream as a pipeline and a pipeline as a stream. When you do that, you take kind of a performance hit. So generally, you want to be, straight on stream or straight down pipelines, and not kind of mix or match. Sort of the same issue that people might have heard of, mixing synchronous APIs with asynchronous APIs. It's just better to kind of stick to one.
Got it. Okay.
Yeah. So the header model of HTTP client today sort of exposes this nice, strongly typed header collection. It lets you add headers as strings as well for the sort of non-standard headers that you might have. Allocating that collection, it may not be something that you want to do. So with this model, you can literally just call write header, write header, write header on a request. There is no collection. If you want to use a collection, you've got to handle that yourself. We're also looking at this kind of interesting thing of preparing headers. So a lot of API requests end up reusing a lot of the same headers. An auth token is a great example. often there are plenty of other headers that are just the same for every request you make, and preparing a header like that allows you to sort of bypass any sort of serialization that happens behind the scenes. You just do it once, and then you can just, copy this byte array directly into your buffer and not have to worry about a whole bunch of other logic. So this is kind of exciting for a lot of API usage, and it's also going to light up something that I think is very cool. HTTP2 and HTTP3 have this feature called dynamic compression. It essentially lets you, instead of sending a full header over and over and over again, you can send it once and say, I'm going to refer to this as header number 1, and then later on you can, just send over 1 instead of your full header, and save some bandwidth. Potentially on the other side, you can reduce the amount of string allocations they would make, that sort of thing. So it's really good for everyone, but every API I've found for HTTP doesn't really expose this to the user. They kind of treat every header as dynamic. And for things like the date header, e-tag, stuff that changes every time, that can be super inefficient. So this API basically will allow you to pick and choose which headers you want to put into the dynamic table. And it should actually allow you to use even less bandwidth and get even more performance out of not just the client, but the server.
Okay. Kind of, stepping back just a little bit as we're talking about this, and now that we've got some kind of understanding of the high level usage, had some people saying, like, what would I use this for? Like, what are the cases? I mean, so for example, somebody was like, hey, would I use this in a JavaScript client? And it's like, no, but would you maybe use it from Blazor? Like, is it possible? Or are you really thinking about server to server interactions, or?
Probably server to server. Blazor is interesting because you can't always open a socket on Blazor. If you're stuck in a browser, you actually are forced to use the fetch APIs. So this will not work at all for most Blazor scenarios. The server to server scenario is really the main one where this matters. And also, like I said, if you're writing a client API and you're not exposing the HTTP client of the user, it's just kind of under the hood, you can base your library on this and give all your users a free performance boost. And you kind of have to pay for it yourself a little bit, but your users would get it for free.
Okay. So like, especially, I think you'd want to think like a microservice scenario for this, probably, right? Where you've got multiple services all interconnecting, and this you're controlling, and you're also able to fine tune everything about your API interactions, and this will give you maximum performance and control and stuff.
Yeah, microservices are actually a great example of where you might want to use this. When you use microservices, you have to really pay attention to your latencies, because talking to other servers takes time, and any performance that you can trim out will usually help in the long term when you kind of combine all of them together. So you could use this for microservices, probably get yourself a boost. One really cool thing that this would let you do in that scenario is, part of .NET 5, we added all these great diagnostics into HTTP client. So you can turn them on, and you will get an event log running for every request, so that you can see a lot of timings. But it's kind of meant for after the fact troubleshooting of, like, someone said this API is running slow, so I'm going to turn on this logging and see what the timings are. But you can't really make programmatic decisions based on that. Using this API, you have such fine-grained control that you can get timings at sort of every level of a request. and really use that to make decisions like maybe this server is taking a little bit longer. I'm going to try making requests on a different server that's less loaded, that sort of thing.
Oh, right. Okay. Wow.
Yeah. So one thing that might be interesting to people is with HTTP client, we have this nice HTTP content object that sort of wraps any content you want to send or receive, such as a JSON object, a stream that you send a file over, that sort of thing. This API, we're kind of going hardcore on it. So we're saying we don't want the allocation for the stream object. So you're actually going to see just a write content method directly on a request that you need to pass some bytes to. And we kind of give you wrappers on top of that. So if you need to use stream, because a lot of .NET does, you can wrap it really easily and sort of pay for the allocation yourself, but it doesn't force that on you. It's, don't pay for what you don't use.
Okay. So there's mention there, the expect 100 continue. What's the current kind of state of 100 continue? Because it's one of those things where I run into every few years where it's like, oh, this thing isn't working. I need to deal with 100 continue. And then I fix it. And then I forget about it.
So 100 continue is not a feature most people use. So what it does, you can essentially, if you're going to send over a really large chunk of content, like maybe you're uploading a 100 megabyte file, expect continue allows you to say, process my headers, and if you want me to continue sending the rest of the content, you're going to send me this 100 continue message, and I'm going to start sending you the content. If you don't want me to send you the content, then return something like a 404 or a 500, something like that. And it's not the best for performance, at least on HTTP 1, because if you don't send the content, the only alternative is to kill the connection and reopen it. Which it definitely has some performance implications, and that's kind of why people generally don't use this. But one interesting thing about this API is that HTTP client hides all of that from you today, so it'll just do that for you. With this, you actually have all of these informational responses, so everything in the 100 to 199 status code. It will return that information to you. So if you're doing something really interesting on your server, and you can use these informational responses somehow, you actually have full visibility into them. So we do make it easy to skip those if you want to. And we're going to have some APIs at a higher level that will implement the full expect continue logic for you if you need to. But most people actually don't need it. So I think for the majority of people, you can leave that layer completely out of this and, remove some logic, get yourself just a slight bit of extra performance by not having some code around.
There was one thing as you're mentioning the kind of like how like returning a 404 or kind of killing the stream. And I saw as you scrolled past it above, there was a go away. There's an implementing go away. I've never seen that before. What is go away?
So HTTP 2, when a server is shutting down, it will send you a message saying go away.
Nice.
It's essentially saying, I'm going to shut down, and it will tell you the last request that it plans to process, allowing you to, continue processing those requests as usual, but anything else you might have sent the server, you can immediately know the server's not going to actually do anything for these, so I'm going to shut that down and try it on another server, another connection. HTTP client handles this for you today, still. So this is another Another feature that you will have access to here, again, I expect many people won't care about this, but if you're, say, implementing a custom connection pool, this is really important for where you route requests to, knowing when you need to open a new connection, that sort of thing.
Got it. Okay. So I made you scroll back up. You were down to the compositional APIs, I believe, right?
Yeah. So this is where you get all the features that HTTP client has. That we want the low-level APIs to be just the protocol, no opinions. It doesn't do anything for you that's not directly in the HTTP spec. The compositional APIs are where you get sort of the nice-to-have features. HTTP client and sockets HTTP handler. They handle, decompression, redirects. They provide this really nice connection pool. It will do all the version negotiation involved in selecting HTTP 1 or 2, and in .NET 6, 3. It'll handle authentication. These are things we want to add as a higher layer in this stack. So you may not care about automatic decompression. You may not care about redirects, that sort of thing. So if you don't need it, you don't need to layer it on. But if you do need it, the current goal is that it will all work with the same abstraction, so you can just write your code once and kind of pick and choose the features that you want to add.
So I could start by the higher level compositional API, and then later on, if I'm like, this is all in a microservice where I control everything, I don't need redirects, then I can go in and kind of tune that.
That might actually be a great way to handle this. You generally don't know exactly what you need when you're developing something. So starting from a point of having all of your features and then sort of peeling them back later once you really know what your service is doing could be really great.
Okay.
Yeah.
Cool.
So this is kind of where the expect continue would be handled. We might have some JSON extensions, like we added the JSON extensions for HTTP client. We might have these here. This is where we would do sort of the header parsing. HTTP client does this for you today with all of the strongly typed header collection. But because these APIs here are just going to be returning you a byte array of what the header value is, we want to provide some parsers for you so that you can pull out the ones that you want.
Okay.
And then we kind of have the high-level APIs. This is essentially just a wrapper around the low-level APIs that gives it compatibility with HTTP client. So if you have existing code that's using tons of HTTP client today, you probably don't want to rewrite it. Maybe you do. Maybe you want to start rewriting it in chunks. This is a great way to allow you to have sort of that extra level of control and still use the high-level APIs until you're ready to move on.
Great.
Yeah, and sort of a tentative timeline of how we're imagining rolling this out. We're really focusing on just the low-level APIs to begin with, so that the people who need maximum performance, maximum control will have that. And then we're going to start kind of adding the higher level features on after that.
Okay. Awesome. Okay, so there's a lot of information here, and I think you've also got some code samples. Are we ready to dig into those? Because it's good to have the concepts, but then I think also to be able to see you've actually written out like some implementation here.
Yeah. So as I mentioned, this was kind of a research project, and it ended up really showing some fruit and got the .NET team very excited about it. We're all super excited and want to start implementing this fully. So, but there is an implementation, at least for HTTP 1. I will show you the Network Toolkit website in a second, but I kind of wanted to demonstrate for you a little bit, sort of how this would be useful for you. So here, this is kind of a weird application, perhaps. It's I'm going to run it through a profiler. So when you run things through a profiler, oftentimes you want to do it in very large amounts. 10,000 is a really nice round number, and I'll show you why later. But this is actually making a request based on the Azure Table Service API. I found this API to be a really good example of something that involves a lot of headers, that are constant to a request. They repeat themselves, that sort of thing. I won't run the profiler for you because it takes a little while to run on this kind of slow laptop. But I will kind of show you the output of this profiler. And this is the sort of thing that you will see soon. David Fowler would, be jumping and his head would be exploding. Here we are. There we go. Here through, looping through making requests 10,000 times. If you've never seen this profiler, it's super useful for seeing, where you're making your allocations, what's really hurting you. First off, you can see kind of up here this timeline. Mm-hmm. Every time you'll see it go up and up and up and then jump down. So every time it jumps down, that's when you're getting a garbage collection. And you can see running 10,000 times, we had a fair amount of garbage collection. And that's kind of some of the overhead that we're trying to avoid. So if we look down here at all these allocations that were made, you can see that there's just a ton of them. Mm. And, strings especially, all over the place. This guy is for the strongly typed header collection. So there's a very rich programming model here that makes this super easy to use, but you don't always need this. And one thing that this kind of hurts you sometimes is you'll notice here that I'm sending this request and getting the response content, but I'm not checking any headers that the server sent me. Mm-hmm. HTTP client doesn't know that you're not checking the headers. So it's still going to allocate for all of them behind the scenes, even if you don't use them. And that's something that I really wanted to avoid with this API.
Yeah, okay.
So
I had a question, by the way, the profiler use. Raja was asking, what's the name of the profiler? And this is just the built-in Visual Studio.
Yeah. So if you go up to debug, I don't know if this is available in all the versions of Visual Studio, so you'll have to check, but just go up to debug and performance profiler. And right now I'm just using the allocation tracking here. And you just click start, and as soon as it's finished, you get this nice chart with all this data here. Super cool. Useful. I encourage everyone to use it.
And I love how you're showing this example. This is like the classic GC case, right? Where it's you keep allocating, you GC, you dive in performance, and then you start all over again.
Yeah, and you can also see here, we ran 10,000 requests.
Yeah.
So you're allocating 10,000 request messages, but then you also see appear these strings. You're allocating 20 strings for every request. Wow. Which, it may or may not be a lot to you, but you can see the effect that it has on garbage collection and the, every time you run a GC, .NET is pretty quick with GCs these days, but you're going to see a small performance hit every time this happens. It's going to affect your 99% latencies, that sort of thing. So anything you can do to avoid it is fantastic.
Yeah, and good reminder that we have people of all different backgrounds. Some people don't know .NET or whatever, which is awesome. Welcome. And GC, Sean reminds us, is the garbage collector. So that's the automatic memory management in .NET, where it's saying after a while, hey, this memory has been allocated for these strings, and now we don't need them anymore. And now we can go clean up memory. But that takes time and it slows down your performance because your application basically stops while that's happening, right?
Yeah. So I mean, .NET it manages allocations for you, and it keeps track of everything that you're using. And it, as soon as you've used a certain amount of memory, it will say, "Okay, I want to clean some stuff up, so I have room for more allocations later." And that's when a GC happens. And it will look at your entire object graph, find the ones that you don't have references to anywhere, and just get rid of them, which is really great for ease of use. But it's something that you have to keep in mind if you're really aiming for performance, because you want to avoid the garbage collections.
Cool.
So here's kind of what this looks like with these new APIs. Also, keep in mind, these APIs, this is still kind of a research project. So these APIs, totally free to change. We're kind of drilling down into them right now, actually. So this should give you kind of an idea of what we're looking at, though. So you'll notice up here, these connection factory bits exist. These will probably not be in the final API. They're kind of some ease of use utilities that I have in here that allow you to make connections slightly easier than opening a socket and stuff all on your own. But you really get to kind of the meat of it here, because this connection is established here. So I'm just saying, I want to interpret this stream as HTTP1 now. So already I'm showing you kind of, you're in full control of opening this connection yourself. I'm not using a connection pool. I'm using a single HTTP connection. And then you'll kind of see these byte arrays here. Part of the performance that we get is by not using strings, because HTTP is either ASCII or it is just bytes, encodingless bytes. And every time you use a string, we kind of have to translate the UTF-16 into these bytes, and there's a small performance hit for that. So if you have things that you're constantly repeating in a request, you can, kind of encode them yourself as bytes and then use that byte array later on. I'm also showing the kind of prepared header concept here. So the Azure Table Service API has a lot of things that don't change. And I find many APIs are like this. Most people have some sort of authentication token. The accept header kind of tells the server what type of content you're expecting in return. And in this case, I want JSON. The content type says the type of content that you are sending the server. This version tells the table service API what version of their API you're using, so that they can kind of run the versioning for you. They clearly did not have the current ASP.NET Core versioning support in it when they were writing this. But this is an example of commonly repeated headers, and I think tons of APIs have this. So you can see here, I'm just preparing that ahead of time because they're not going to change later on. And down here, I have kind of my loop. Again, we're running it 10,000 times. And I need to first create a new request on a connection. Something that might interest you is that this is nullable. This is because there are many cases where a server or the client will need to just close the connection. And this kind of lets you know, like, hey, the connection's closed or it's not accepting new requests. You need to manage opening up a new connection yourself. Again, this is the low-level API. Sort of the higher levels will open these connections for you and manage this sort of thing. But again, here, you're in full control at this low level. I know that for the demo's purposes, we're always going to have an open connection. So I'm just pulling the value out of it and assuming that it'll work.
Mm-hmm.
Here, you need to configure a request, and this kind of gets into you need to know a little more about HTTP. So based on if you know your content length and if you're sending trailing headers, so most people probably don't know about trailing headers because they're kind of rare, but you have your main headers at the start of a request, and then after you've sent content, you can actually send more headers. Usually this is, you might send a hash of the content so the server can verify it, that sort of thing. But based on what you're using these, if you're using these, the sort of encoding that happens behind the scenes will change. There's something called chunked encoding. So you kind of need to tell this what you intend your request to be. And then you can kind of write the request line. So this is the, get/http11. And here I'm passing in those byte arrays. So it's able to just, and I'll show you this later, very efficiently put these over into a request buffer. And then I can write all of my prepared headers in just one call. And, behind the scenes, this is pretty much just copying one byte array into another. So it's super fast. And for, if we go over here, you'll notice that I'm setting this date header. I'm also setting a request ID. And these are the two headers that change with every request. So here I'm using the UTF-8 formatter, which is super nice. It lets you basically call int.toString, but instead of allocating a string, you just write into a byte array.
Mm-hmm.
We
had some questions on the formatting and stuff earlier. UTF-8 is kind of the standard because that's what's used for these protocols, right? So
UTF-8 actually is not used by HTTP.
It's the formatter that's which one is it?
Sorry. So UTF-8 is compatible with ASCII.
Okay.
And all I care about is writing out ASCII. And I know that for a date and for an integer, it's not going to use any sort of, Japanese characters or something like that. It's just going to be ASCII. So the UTF-8 formatter still works really great for that.
Cool.
So this kind of shows you that, I wrote out my prepared headers above, and here I can write individual headers saying, this is the name, this is the value, and again, this is pretty efficient. It's just more copying behind the scenes. And then I can write my content. So I only have one call to writing content here, but you can call this as much as you want. So, a typical scenario that you might find is you're reading content in a file. Maybe you're reading, a few kilobytes at a time. You can call just write content for, every chunk that you read. And after you've written all your content, all your headers, you call complete request. So this tells the library that you're completely done. It flushes anything that hasn't already been flushed for you from previous calls to the network. And some cool stuff we're using in this is that for many scenarios, this will result in just a single I/O call, which is very important because every I/O call you make, such as sending on a socket, writing to a file, it's it's pretty inexpensive, but it's expensive when you're at this level because it transitions from your application into your kernel and back to your application, and that's not free.
Yeah.
So you want to do it as few times as possible, and in many cases, we can do it just once for each request, which is perfect.
That reminds me of another question that came up earlier, which was, you were talking about, we've been talking mostly about memory use, but there's also things like CPU use. And I think that's an example of a case where those transitions is a place where that does work the CPU harder, right?
Yeah, and part of the performance that you'll get out of this API, in certain cases, you might get better network performance, just slightly. But most of the savings here are CPU usage. And depending on your request makeup, this tends to be about 2 times as fast as HTTP client, up to maybe 10 times as fast in terms of CPU usage. Your
Wow.
request will still be bound by the network, but if you've got a lot of stuff and your server's pegged at 100% CPU, this could let you handle 10 times the amount of requests.
Okay, crazy idea I've got here. And going back some to we were talking about like source generators and scaffolding and stuff, because I see here this makes sense to go through and finely tune things. I know I'm only using HTTP1. I know which headers I'm using, that kind of thing. But it almost makes me wonder if we could like hit a Swagger doc, like ping the server,
Mm-hmm.
understand what that communication is, and generate some code based on that. Like, okay,
I love it.
we
I think that would be an amazing project. If someone wants to write that for this, I think it'd be a fantastic proof of concept to kind of show how you might use these APIs to get a performance boost without really needing to use them. So you get kind of the benefit for free. I think that's a great idea.
that would be, and then you could go through and look at the code and say, oh, actually, I do want to support HTTP2 or whatever, and you could go and tweak it. But at least you'd have something kind of based on usage to figure out what you're using.
Yeah, and this is all through, this is not an HTTP1 request. This is just a request for HTTP. This is abstracted for you. So if you want to make this HTTP connection an HTTP2 connection or a pooled connection, all your other code will just be the same. You just change this one line, and you can change how many features you expose.
Cool, cool.
Yeah. So one goal of this library is HTTP 2 and 3. They have this kind of rich extension model that allows you to add features to the protocol based on whatever your app supports. There are one or two standard ones right now, but really anyone can do anything. But it makes programming for it kind of difficult because the extensions can pop up anywhere. So you will see kind of a weird model here of needing to read to content multiple times.
Hmm.
That's because HTTP2 has this thing called a data frame, and it will send you content in a data frame, and it might have something after that, and then more data. So this is kind of you saying, just give me each data frame. Again, it's harder to use, but it puts you in control, and there are APIs that let you get at those extensions that HTTP client doesn't offer today. Like it just ignores them for you, and this one exposes that to you.
Okay.
So here we're just looping through each data frame, which on HTTP1 there's just one. So if you know you're on HTTP1, you can get rid of this while loop here, and then reading the content. So this is kind of a standard loop that you'd see over a stream, except it's not a stream. It's directly on the request. And finally, once I've read all the content, I pull out that string of the content that it sent me. And you will see here, I ran this through the profiler, and it's very different.
Whoa.
Where did all those GCs go? They're just not here because we allocated almost nothing. You'll see kind of this little hump here of when we actually did allocations, and then as soon as we hit steady state, it just zeroed out. The only thing we allocated was a string, and that was my own doing. The library didn't do that for you. So if you didn't allocate the string, this would be zero allocation program. And you can see here, 10,000 allocations for a string, and the next one is, just small things that we cached.
Wow.
Yeah. So really cool, and even went so far as to, if you're familiar with how async methods are used, we actually manually implemented some without using the async keyword to make sure everything is nice and bundled and close in memory and things like that, and saving the allocation for the async state machine. So we used all sorts of these tricks behind the scenes to make it better for you. You don't necessarily need to care about that, but it's pretty cool to see.
So a few questions coming in. One, and again, it's awesome. We've got some beginners. We've got a huge variety of programming levels on, which is cool. That GC, oops, sorry. This one actually, this was the one I meant. But questions about the GC. Should that string have been GC'd? And I think it's just we didn't allocate enough of them, right?
Yeah, so the GC, it kicks in after it notices some memory pressure. So when you run .NET, it kind of knows how much memory your system has. It knows how much it has available to it. And to give you performance, it only runs a GC when it has to. And it says, I'm kind of reaching the limit of what I think I can use, so now I'm going to run a GC. We just didn't run into that limit because we allocated so much fewer objects in this, so no GC had to run.
And so to wrap that up, here a question from Raja about should we forcefully GC? And the answer, and correct me if I'm wrong, but you don't want to GC basically ever or as rarely as possible. So the goal here, like some people are like, oh, that slope's going up, but it's like, no, you're going to allocate some memory over time, but the goal is that you don't hit that limit and have to garbage collect, or you do it as rarely as possible.
Yeah, so I mean, eventually, you're going to have some allocations in your own code probably. For a long-running app, steady state, a GC is going to happen, but it's going to happen because of your own doing, not because of the HTTP client. And you can see here, it kind of topped out at about 15K objects.
Yeah.
And if we go over to this one, you'll see it topped out at about 71K objects over and over and over again. That's sort of the upper limit that we didn't reach before it would have ran a GC.
Wow. Okay, question from Jonathan. He's sold. When do we get it? Is this going to be in the BCL, separate library? What's happening?
Okay, so I have to be a little careful here. I don't want to promise you things. We're still deciding.
This is early prototype. This is your personal GitHub repo, and this is a design, kind of a request for comment level, right?
Yeah. So what I can tell you is that the team is very excited about this. We are going to try to put out a release in the .NET 6 timeframe. It would not be built into the framework, or I shouldn't say framework, into .NET 6 proper. It would be a separate NuGet package. Again, this is just a discussion we're having. That's where we want to go. It may not go there. But we all really want it to, so we're pushing on it.
Okay, so people can, and I'll share the link again. Like we've shared, and at the end of the stream we will, and it'll be in the YouTube description and stuff. But people can grab this repo and try it out, run it locally, play with it.
Yeah.
Go ahead.
So this is the repo that you're talking about.
Yeah.
This is actually going to be moved. We are creating something in the .NET Runtime Lab. So you're going to
Nice. Okay.
see, probably this week, you're going to see this pop up as like System Net HTTP Experimental, some weird name like that. And so you won't have to go to my repo, and you're going to start seeing contributions from, other people who are on the .NET team. Including you, if you want to submit a patch and help work on it. That I would love that. If you just want to use it and try it out, I actually have this on Nougat, so you
Oh,
can
nice.
just go ahead and install Network Toolkit, play around. I can't guarantee you that it's bug free because there are many tests that are run on this, but it takes a while to weed out bugs on brand new code. So don't use this for production, but please play around with it.
Cool. Okay. And then so this is an early kind of like, we want people to look at it, see, understand like, hey, this API would work for me, or hey, I tried it and it doesn't work for me because I need this other thing.
Yeah.
What's the best place for people to leave their comments?
So if you have a comment right now, you can go ahead and leave, just create an issue on my repo. If you want to wait about a week, you can create one on Runtime Lab. You can also, talk to me on Twitter. If you want to chat live with me, if you go to my main profile here, you'll see all these different .NET communities that I'm a part of. I monitor them pretty regularly.
This is cool, by the way, because again, we had like a bunch of new people that are just brand new, learning C#, learning .NET for work, that kind of stuff. And this is cool that you list some of these places. There's Reddit, C# and .NET. There's Discord. I mean, we've got a lot of on the .NET site. There's a community tab, and there's like we link over to all these other communities. So
yeah.
Obviously, if you're watching a live show or YouTube, those are places, but we're kind of all over the place. And I appreciate that you and other people on the team are monitoring these, like the Reddits and stuff and Discords. It's really cool.
I love talking to our customers. I was once just a customer of .NET. And I was the type of person who was already in these talking with people about it. I love to chat about .NET and help new users, help advanced users who need an opinion on things. I just love talking with you.
Awesome. Okay. I copied this over into the chat, and then it's also in the community links. And let me. Which includes the stuff you showed as well as the links I showed at the beginning. So I'll put that in the chat as well. This is awesome. I think I'm selfishly happy because I skimmed through it. I'm like, I think I kind of get it. And having you walk through it here, I totally see both. I want this 5 years ago. Like, this is really, really useful. I'm excited to see this.
Yeah. Behind the scenes, the .NET team has wanted to do something like this for a while. So we are all super excited that we've kind of finally get to play with something like this.
Very cool. All right. Well, I think we'll wrap up there. I'm excited to see this go forward, and thanks a bunch for your time.
Yeah. Thank you. Very lovely being here.
Awesome. Okay. Thanks, folks.
Bye-bye.